Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question, longest common subsequence. Given two strings text1 and text2, return the length of their longest common subsequence. If there is no common subsequence, return 0. A subsequence of a string is a new string generated from the original string. When some characters can be none, deleted without changing the relative order of the remaining characters. For example, ACE is a subsequence of ABCDE. ABCDE itself is also the subsequence of ABCDE because by definition, the characters deleted can be none. So you can choose to delete nothing from the original string. And then the second point is the relative order of the remaining characters are not changed. So for example, ACE is the subsequence of ABCDE, but if you shift the order, let's say C comes before A, CAE is not a subsequence of ABCDE because the relative order changed. A common subsequence of two strings is a subsequence that is common to both strings. So which means this subsequence is the subsequence of text1 and text2 as well. So that's the common subsequence. Let's take a look at example 1. Text1 equals ABCDE, text2 equals ACE. The output is 3. The longest common subsequence is ACE, and the length is 3. Example 2. Text1 is ABC, text2 is also ABC. The output is 3. The longest common subsequence is ABC, and the length is 3. For example 3, text1 is ABC, text2 is DEF. There is no overlap in characters, so the output is 0. There is no common subsequence. So then how to solve this? So I plan to solve this one utilizing 4 different solutions. The solution 1 is going to be a recursive function, and then that will actually lead to the time limit exceed. But it's very important to understand the solution, the idea to solve this problem. So that's kind of our starting point for solution 1. And then solution 2 will be the optimized solution, still utilizing recursion. And then solution 3 is going to be dynamic programming. So usually we call that bottom-up approach, and I will explain why it's bottom-up. And by the way, for the solution 2, the recursion with memoization, so it's called top-down approach. And then the solution 4 for dynamic programming, still bottom-up, but I will show you how to solve it with optimized space. So those 4 solutions, the reason why I'm trying to show you 4 different ways to solve that is just trying to help you grasp the idea for that. And also, it's a good, this problem is a very good one to illustrate different approach. So probably you will see like top down, bottom up a lot of times if you are beginners, and then without you're probably wondering what does that mean. So now I'm trying to solve this one in 4 different ways to show you the recursion and then also the dynamic programming approach. So let's start with the recursion. So let's take a look at example 1, how to solve it. The first situation is, let's say, for text1 and text2, let's take a look at the character at position 0. So the character at position 0 in text1 is A, and then the character at position 2 at position 1 in the position 1, which is the index 0 in text2 is also A. So A equals to A. So we find the first characters of the common subsequence, that is A. And then we know that, okay, the length is at least 1. And then what are we going to do next? So since we already find at the position at the index 0, we already find the first character of the common subsequence, that is A. So we move to the next position. We check the substring. Okay, so what is the longest common subsequence between the substring BCDE and then the substring ACE? We start by looking at the first character of that substring. So in that case, it's B in text 1 and C in text 2. Remember, for A, we already finished comparison, and we already know that A is the first letter of the common subsequence of tax 1 and tax 2. Now we are trying to find the second letter. We do that by comparing the substring BCDE of tax 1 and substring CE of tax 2. So we start looking at the first character from the both of the substrings. B does not equal to C. So in that case, what should we do? Okay, so in that case, if the character B does not equals to the character C, maybe we can break down into two different scenarios. One is, okay, for the substring B, C, D, E, what is the common subsequence between this substring and then the substring E? So which means, okay, since B does not equal to C, so let's move on to the next position in the text 2. The other scenario is, let's say, okay, so how about let's keep the substring from text 2, CE, and then try to compare with the substring CDE in text 1. In that case, we know that B does not equal to C. So in that case, we move the pointers, like starting from position for the character B to the next position. And then after we done the comparison for those two, after we calculate the value for the two scenario, what should we do? We take the maximum value because we are trying to get the longest common subsequence. So that's kind of the idea to solve it, utilizing recursion. So let's try to code. So define a helper function. I call it LCS. And then I utilize ij. So I indicates the position we are currently looking at in text 1. And then j equals to the indicates the position we are looking at in text 2. So basically, I and j are the starting position of the substring. We are trying to find the longest common subsequence. And then what are we trying to do? So we are trying to do the comparison. So let's say if the text 1 I equals to text 2 j. So in that case, we just get the return. So the 1. So since we already find the one character, and then we move on to the next. So what does this mean? Which means like, okay, we first look at the substring starting at position I in text 1, and then substring starting at position j in text 2. And then we first check their first character, so which is the position I and j. And if we find that they equal to each other, so we know that, okay, the length is at least 1. And then we're trying to look at, okay, the substring starting at position I plus 1 and position j plus 1 in text 2. If they are not equal to each other, then we are trying to return the maximum of LCS I j plus 1, LCS I plus 1 j. Okay, so if the character at position I and j, they are not equal to each other, then in that case, we are trying to compare two different scenarios. One scenario is the substring starting at position I in text 1 versus the substring starting at position j plus 1 in text 2. The other scenario is the substring starting at position I plus 1 in text 1 and the substring starting at position j in text 2. And then after compute the longest common subsequence in two different scenarios, we just compare them and then return the maximum value. So what is the base case for the recursion? So which step, when should we stop and return the base case? So in that case, if let's say we finish traversing either string, let's say if I equal to the length of tax1, or j equals to the length of tax2. So in that case, we just return 0. So that's our base case. So after finish coding the recursive function, let's try to return the LCS 00. Initially, I equal to 0, j equal to 0, because we are trying to compare the entire string tax1 with tax2. Let's try to run the code. Okay, we passed the first test case for example 1. Let's try to submit it. This one will lead to the time limit exceeded error. Okay, it shows the time limit exceeded. So let's try to analyze why this is the case. Let's try to take a look at example 3 and then try to walk through the calculation step for that one. So first, let's say we are trying to call LCS 00, and then in order to call that, so 00, we compare if A equals to D. No, they are not equal. So in that case, we need to get a maximum of LCS 10, LCS 01, and the LCS 10. So, okay, when we are trying to calculate LCS 00, we need to try to get the maximum of LCS 01 and LCS 10. Okay, to calculate the LCS 01, we first look at, okay, if A equals to E, no, they're not equal. So in that case, we still enter this else condition. So in this case, we still need to return the maximum of LCS 02, LCS 1, 1. And then let's try to calculate the LCS 10. So that's the LCS 1, 1, and LCS 2, 0. So basically, in order to calculate LCS 00, we need to calculate the maximum of LCS 01 and the LCS 10. So in that case, let's try to calculate them respectively. So to calculate LCS 01, once we enter the recursive function, we know that in order to calculate the LCS 01, we need to calculate the maximum of LCS 02 and the LCS 11. To calculate the value for LCS 10, we need to get a maximum from LCS 11, LCS 20. So now, did you see the problem? So, okay, to calculate LCS 01, we need to calculate the LCS 11. To calculate the LCS 10, we also need to calculate the LCS 11. So basically, we are calculating the LCS 11 repeatedly. So that kind of causes a problem. So how to avoid those repeat calculations? That's kind of why we lead to the second solution, recursion with memoization. That's usually called the top-down approach. So before coding that solution, the idea for that solution is, let's say, we are trying to store the value we already calculated before. Let's say if we already calculate the LCS 11, we're just trying to store or cache that value so that the next time when I need to call the function LCS 11, I just check if that value has already been calculated before. If it's already been calculated before, I just fetch the value instead of recalculating it all over again. So that's kind of the idea. The reason why it's called the top-down is more like, okay, so we are still kind of in this recursion, so uh, utilizing this recursive approach, and then we're trying to solve this problem utilizing the top-down approach. So before coding up the recursion with memoization, let's try to first analyze for this solution one, the time limit exceeded solution. What is the time complexity? So for this solution one, the time complexity is actually O2 to the power of n. So why that's the case? Let's say, take a look at the worst case scenario. So in that case, we do not have the uh, overlapping characters in the text 1 and text 2. So which means each time I call the recursive function, we need to branch it out and then compute the maximum value between LCS I j plus 1 and LCS I plus 1 j. So that's two different scenarios. So in that case, that's kind of is y2 to the power n exponential. Okay, so let's try to code up the solution 2. I'm just going to modify on top of the solution 1. So this is the solution 2. So that is the recursion with the memoization, the top-down approach. So in this case, I'm just trying to store the value already calculated. I'm utilizing a Python dictionary. So in that case, while trying to locate, fetch the value for for ij, the time complexity to fetch it from the cache will just be O1 for the dictionary. So in this case, if let's first check if this ij has already been computed before. If it's already been computed, so we just return fetch the value from the cache. Okay, if the value is not calculated before, so in that case we need to calculate it. So instead of directly return it, we want to first put the value in the cache. So in that case, the cache ij equals 0. Else, if the characters of the ij text1i equals to text2j, so in that case, my cache ij equals to 1 plus LCS I plus 1 j plus 1. Else, let's try to assign this one to cache. Okay, and then after that, we're just trying to return the value from the cache dictionary. So, okay, so this is the solution 2, recursion with memoization, the top-down approach. Basically, compared with the solution 1, I'm just adding a data structure dictionary, and then I call it cache. So basically, cache is a dictionary I used to store the value I already calculated before. When I enter this LCS function at each recursive step, I first check if this ij has already been calculated before. If it's calculated before, it's already in the cache. So in that case, I just return the value computed before. In that case, I do not need to compute the same value over and over again. If it's not exist, so in that case, I do the calculation. So whenever I do the calculation, I just assign this value to the cache ij. And then in the end, I just return the value from the cache ij. So let me try to run the code. Okay, so in this case, this pass all the test cases. So what is the time complexity for this one? So the time complexity should be OMN. So in that case, M and N are the lengths for task 1 and task 2 respectively. So now let's look at the third solution. That is the dynamic programming approach from the bottom up. So in this approach, what I'm trying to do is let me keep track of it's kind of similar idea to keep track of, to have something similar to the cache, to keep track of the value already computed. But in that case, instead of doing it top down, utilizing recursive approach, I'm going to do it in an iterative approach from bottom up. So let me have a matrix. So for the matrix, let me get the M equals and N equals to the length of task 2. Now I initialize an empty matrix. So that this matrix, the dimension for this matrix is M plus 1 times N plus 1. So what does this matrix represent? So index dp I j. This is similar to our, remember, similar to our recursive function. So basically it's kind of the, we are trying to compare the substring. But in this case, it's substring ending in position. The substring starting at index 0, ending in index I in task 1, and then j in task 2. So in that case, the value, so basically the return value is actually dpmn. So that's kind of why it is a bottom-up approach. So let's try to do the calculation for I in range. Oh, I made a mistake. Okay, usually iterative approach, bottom-up is much faster than the recursive approach, the top-down approach. So in this case, let me try to reiterate on this approach. So basically, I'm utilizing a matrix dpij, and then what does it represent? It is actually I is the index, the substring, starting at index 0, ending at index I in text 1. J is the substring, starting at index 0, ending at index J in text 2. So, and then in that case, the return value is actually dpmn. So basically, that means we are trying to compare text 1 with text 2. And then when we start doing the comparison, let's say if the text I minus 1 and text j minus 1, if they equal to each other, in that case, the dpij equals 1 plus the dpij minus 1, I minus 1 and j minus 1. Else, is kind of equal to the maximum from the dpi minus 1 j and dpi j minus 1. So the idea is similar to kind of how we did it in the recursive approach. Here we just do it in the bottom-up way. So in this case, the time complexity is O-M-N, and the space complexity is O-M-N as well.